Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is find the x sum of all k long subarrays part 1. Now the problem category is of easy level, but I would say this problem is not that easy, but we are going to break the problem in small chunks and we are going to solve it like it is easy. Now the given input in the problem is nums, which is an integer array, and k and x. So we are given total 3 inputs, one integer array and 2 other integers called as k and x. We are given a task in the problem that we have to find an array as an output. So for this particular input, the output is actually this particular array 6, 10, 12. Now how are we going to reach to the output is we have to consider the k elements in the array. So let us say we have to find the 6 elements, right? So first 6 elements, that's one window. In this one window, you will have to find an answer and the answer will be 6. So for the first window of 6 elements, 1, 2, 3, 4, 5, 6, 6 elements, basically this is our array. The answer is going to be 6. Now you have to find the next window of 6 elements, which is going to be 1, 2, 2, 3, 4, 2. This particular array 1, 2, 2, 3, 4, 2. For this particular array, or I would say sub array, the answer would be 10. And for the last set of sub array, which contains k elements 1, 2, 3, 4, 5, 6 elements, basically this particular array, the answer is going to be 12. Basically we have to find all the sub arrays of size 6, or I would say size k, and then for every sub array you have to find what is the x sum of all the k long sub arrays. Now how to find the x sum? Now try to see the problem. You are given x sum and k long. This x and k is given in the input. When we say k long, it means you have to find all those sub arrays which are having length of 6 or length of k. So we have 1, then we have 2, and then we have 3 sub arrays. For every sub array we have to find the x sum. What is the x sum? Basically when the given value of x is 2, then you have to find in every sub array what is the 2 most frequent element, that is those element who has the most frequency. So in this particular array, the elements are 1, 1, 2, 2, 3, 4. So you have 2, 2 times, you have 1, 2 times, you have 3, 1 times, and 4, 1 times. Find the 2 elements, find the x elements which have the most frequency. So the frequency of 2 and 1 are most, right? It is 2. These 2 elements have the most frequency. Basically the element 2 and the element 1 who have the frequency of 2 and 2, and 3 and 4 have the frequency of 1 and 1. So the top 2 elements who have the most frequency is 2 and 1. So you have to find the sum of all the 2 and all the 1 in your array. So you have 1 plus 1 plus 2 plus 2 will be equal to 6. Let's try to understand it again with the next sub array. What will be the next sub array? It will be 1, 2, 2, 3, 4, 2. And when we say the next sub array, it is actually going to be a sub array in which one element is added, another element is removed. What I mean to say is, if this is your first sub array, let me actually draw this. So if this is your first sub array, it contains k elements 1, 2, 3, 4, 5, 6. We have 1, 1, 2, 2, 3, 4. Now if you want to find the next sub array of 6 elements or k elements, it will be you will include this 2 and remove this 1, right? So you got 2 and you remove this 1. So now your sub array is 1, 2, 2, 3, 4, 2. 1, 2, 2, 3, 4, 2. In this particular sub array, you have to do the same operation. First of all, find out the x elements or the 2 elements which have the most frequency. So in this particular sub array, you are actually adding a 2 and removing a 1, right? So the frequency can be easily find out by just updating this particular previous frequency. You add a frequency in the 2. So now the 2 is 3 times, right? And the 1 is not 2 times but 1 times. And the remaining element frequency will be same. So you have 1, 1 times, you have 2, 3 times, and you have 3 and 4, 1 times. In this particular array or in this particular sub array, find the 2 most frequent element. So one of the element will be 2, right? This particular element 2 is having the most frequency of 3, right? But the remaining 3 elements have the same frequency. 1 is 1 time, 3 is 1 time, and 4 is 1 time. So in this case, you have to consider the element which is the highest. 4 is the highest, right? So you will consider 4. So now you have to find out the sum of all the elements which are 2 and 4 in this particular sub array. So it will be 2 is 3 times. So 3 into 2, 6, plus 4 is 1 time. So 4 into 1 is 4. So 6 plus 4 will be 10. And same you can find out from the sub array as well. 2 plus 2 plus 4 plus 2 will be 10. And similarly for the last sub array, again you are doing the same thing, right? In the previous sub array, you are just adding an element 3. This last 3 element is added, and the first element of your previous sub array, that is 1, will be removed, right? So now you got another sub array of size k. The sub array is 2, 2, 3, 4, 2, 3. 2, 2, 3, 4, 2, 3, right? Again, if you want to find out the frequencies, since 3 is getting added, the frequency of 3 will be now 2. 3 is 2 times, and 1 is getting removed, so the frequency of 1 will now not be 1 but 0, right? So this is the frequency. In this, what are the most 2 frequent elements? So 2 is 3 times and 3 is 2 times, right? So take the sum of all the 2 and all the 3, it will be 2 into 3 plus 3 into 2, it will be equal to 12. 6 plus 6 equal to 12. So the answer is going to be 6, 10, 12. Now that's the complete question, right? How are you going to solve this? That's the motto, right? So first of all, just follow the steps. You have an array, find the first subarray of 6 elements, and find the frequency. That's our first task. So let's actually do it. Let's first try to implement the same thing. So let me make the window a little bit small so that you can see the solution. Now, first of all, I have to find the first subarray, right? This is my first subarray of size k. So I can simply say first subarray will be equal to nums up to k elements, right? So we got 6 or k elements of nums. That's our first subarray. Now we have to find the count or the frequencies of each element. So I can simply say count or counter is equal to, we have a counter object in collections which is used to count the frequencies of elements. So we can just pass our array in this, and now we have the frequencies as well, right? Also, let us create another variable called as result. In this variable we are going to store our result. That will be an array. Now I just want to find out in this particular counter, this is my counter, right? In this I am counting the frequencies of each of my element. I want to find out in this particular counter what is the result, like what is the element I need to add. So actually what I can do is I can create a function which will do the same task. In this function I can pass the counters like this, and what I am expecting is that function will return me 6 or 10 or 12. If I pass this particular counter, the function is going to return 6. If I pass this one, it is going to return 10, and if I pass this one, it is going to return 12. So let's create a function, and I can say def ans. This function is going to return me the answer. Now in this answer we have to pass the counter, right? So let's say cnt, it is expecting a counter object. Now we have to make use of heap. That's the first intuition which you have to draw. Why we are making use of heap is actually used to find out what's the max element or what's the main element at a particular time in your given set of data. I want to find out top 2 max elements, and the element will be maximum based on their frequencies. So I'm going to use a heap because I have to find the top 2 frequent element. So first I will find out the first most frequent element, then the second most frequent element. If x is equal to 3, then the third most frequent element, right? The question also says that if you have less than x elements, let's say you have x equal to 2, but the number of elements, the number of unique elements in your array is not 2 but 1. Let us say your subarray is containing all 2's, right? So you will have 2 6 number of times, right? In that case, you can just consider the sum of your array as the result for that particular subarray, or I would say the x sum of that particular subarray, because you just got one element, right? You don't even have x elements, which so that you can find out the top x elements of most frequencies. But we are going to deal with that particular logic. This particular point is given in this particular part of the question. Note that if an array has less than x distinct element, its x sum is the sum of the array. We have to make use of heap, right? Because I have to find the top x frequent element. So let me actually create a heap. I would say heap is equal to an array for now. So heap equal to array. Now I have to go through my frequencies to find out, or not to find out, but to push my elements into the heap. So I could say for key comma value in cnt dot items, it is going to return me the key and value. Basically key is the element 2 and value is the frequency. So the element and the frequency. Now I have to push the elements in the heap. So I would make use of heap queue. That's a module in Python which has implemented the heap feature. Now in this, using the heap queue, I could say heap queue dot heap push. I'm pushing some element in the heap, and the heap I'm using is this particular list. So this is my heap, and what do I want to push? I want to push the key and the value both. So I would make use of a tuple. But I want to make use of a max heap. I need a max heap because I need the top most frequent element. By default, this particular heap, the heap queue module, behaves as a min heap. It is going to return you the element which is the minimum. So to tackle with this, we are actually going to push the elements as negative. So first of all, I have to find the element if that has the maximum frequency. So the frequency is actually stored in the value. So I would say negative of value, so that I could just turn this heap into a max heap instead of a min heap. And when I'm saying that the frequencies are matching, if they have the same frequency, then the element itself will behave as the max element, right? That is 4 will be the maximum here, not 1, because 4 is the highest. So I have to push the key as well, and again I have to push the key as negative. If the value, that is the frequency, is same, then it will do the sorting, I would say, or basically it will give me the max or min based on the key. Now I have pushed the elements. Now I can just create another variable. Let me create a variable called as s equal to 0. Basically this particular variable is going to store this particular result 6, 10 or 12 based on the subarray. So I have this variable. Now I can just run a loop for underscore in range of x. I need to run a loop for x times because I need the x most frequent element, right? One of the check which I need to do is if I do not have any element in the heap, or I could say if we have some element in the heap, then I would pop out some elements from the heap. Basically, the heap is going to have -2 comma -2, -2 comma -1, -1 comma -3, -1 comma -4. Basically, this particular counter object is converted into a heap, right? And the values and the keys are stored in negatives. So if we have some element in the heap, I'm going to pop out the element. I'm going to say key comma value is actually going to be equal to heap q dot heap pop. I want to pop out the element from the heap, and this will give me the element which has the highest frequency. And if the frequency are same, it is going to give me the element based on the highest key. Now, since both the values are negative, I do not need to convert it back to positive, because I actually need the product of key and value, because that will tell me how many keys I have, right? That is, if I want to find out what will be the sum of all the 2's, so I can just say that 2 is my element and it is 2 times. So 2 multiplied by 2, right? So key multiplied by value, that is what I need. And I can say S is equal to S plus key multiplied by value, right? So now I can store the S, that is 6 or 10 or 12, whatever is the output for that particular subarray. And once the processing is done for the X elements, I can return this, return S. Now, why I am using this particular logic, if we have some element in the heap, that is to tackle this particular condition, that if we have less than X elements, then nothing will happen, right? The loop will just flow and nothing will happen. So now we have returned the value of S. Now we can simply do one thing. We can simply pass the counter for each of the subarray and store the S in the result variable. So let me minimize this particular function. Let me go back to our original logic. So first of all, we have this initial counter, right? So we can say result dot append. Let me call this answer function. And in the answer function, I can pass my initial counter. That is going to store the result for the first subarray. For the first subarray, the result is 6. Now we need 10 and 12 for the next subarrays. So I can simply run a loop to find out the next subarrays. I can say for I in the range of starting from k. I need to start from the kth element, right? The element which is at index number k. This is at index number 6, right? 2. Then I would add the 2 in my frequency, in my counter, and I would remove the 1. So for this, let me run the loop for the range of k to length of nums. First of all, I need to remove one element. So I can say counter of nums of I minus k. The element which is at this particular index, I minus k, which is I is 6. If I is 6, then this particular value will be 0, right? So nums of 0 is getting removed. Next time nums of 1 will be removed for the next set of subarray. The counting of this particular element will be minus equal to 1, and the counting of element at the ith index, the new element, will be plus equal to 1. So now we got the counter object for the next subarray. I can again just use this logic. I can call the answer function. In this answer function, I can have this counter, right? I will pass my updated counter, and that will append the result. And once it is processed for all the subarray, I can say return result. Let's just run it for once. So the sample test cases are fine. Let's submit this. Let's see if it passes all the test cases. I think it should. So yes, it has passed all the test cases. The runtime is pretty good. The memory use is just fair enough. But if I just submit this again, I can see that the memory would be improved. It happens sometimes. So now you can see the runtime is pretty fair. The memory use is pretty good, right? So we have solved the problem in a very efficient way actually. If I just show you the solution again, that's our complete solution. We have a simple function, and then we have a simple logic to call that function for every subarray, and we are actually passing the counter of every subarray, and that's storing the result in our list. So guys, that's it for this video. If this video has helped you to understand the problem, that's the main logic, that's the main concern. If you have understood the problem and the solution approach and why we have used the heap, why we are using the counter, everything, if it is clear to you, then make sure that you hit that like button. And if you have not subscribed to my channel as of now, then make sure that you do so. And I will see you guys in the next video. I want to see you guys in the next one. Thank you for watching this one.